Hey everyone, today we are going to solve LeetCode problem number 623, add one row to a tree. It's a good tree question and it will be helping you to understand the tree traversal using BFS, DFS, and this question has been asked in Facebook and Amazon. Let's have a look on the problem statement. Here we have a root of a binary tree and two integers, value and depth. And we have to introduce a row of nodes with value val at a given depth. And they are also saying that the root is at depth 1. Let's try to understand using an example. Let's say in this binary tree, this is the depth 1. And what we have to do is we are given a root to this binary tree and the value and the depth. It means at the depth 2, we have to introduce a row with value equal to 1. So this is the depth 1. So depth 1 will remain same. Now we are at depth 2. At depth 2, we have to introduce a new row. So here and here we will be introducing another nodes to form a new row. So here we are going to have 1, here we have to 1 again, and then as a left child of this 1 will be the left child of 4 in the initial graph. 2, 3, 1, and the 6 will be the right child of this node instead of 4. Now a new level is introduced at depth is equal to 2 as given in the problem statement, and all the nodes are having value 1. So here if you try to analyze that we had to introduce a new level at depth equal to 2. So we have to do some kind of manipulation at depth 1, because after depth 1 we are going to have the depth 2, right? And there is one case as well. Let's say if we have to introduce the variable at depth equal to 1, what we are going to do in that case, because we don't have a depth 0 so that we can have a depth 1 attached. So in this case what we can directly do is we are directly going to attach the new row at the head of our existing tree. So it will be something like this. We are directly going to attach over the head. At depth equal to 2, we are going to attach node after depth 1. If we have to attach at depth equal to 3, what we have to do in this case, we have to introduce a new level here in this case. Here it is null, so we are going to add 1 as a new node, and the right of that one node will definitely be a null. So if we have to introduce it at a depth 3, what will be the new tree? This tree till depth 2 will remain same. So 4, 2 and 6. Now we have to introduce our level at depth 3. So from depth 2 we are going to add values, and these value will be attached to this level. So 3 is the left of 2, so 3 will be the left of this one now, and the 1 is the right of 2, so 1 will be the right of this. So 5 will come here, something like this. So this is our new tree when value given is 1 and depth given is 3. Sorry. I hope you understood the problem statement. So how we are going to approach this problem? First of all, the first thought came to my mind is that I have to introduce a new level. Why don't we just directly traverse, and when we are at depth equal to d minus 1, that is depth given minus 1, at that level we are going to attach left and right child of each node. Or you can say when we are at 2, what we are going to do is I'm going to store the left subtree in a temporary variable, and I will be attaching a new node, and this temporary variable will be attached to the left of this new node. In this way we can do something on this level, but we can also do this in a recursive manner. So the first approach can be BFS, breadth first search, the level order traversal, and the second you can think in terms of DFS, depth first search. In the DFS, what we have to do? So whenever, firstly, we have to handle the case where d equal to 1 explicitly. So d equal to 1 is a special case we will handle explicitly, and all the value of depth greater than equal to 2. What we can do? We can reach till d minus 1, and at d minus 1 we are going to introduce new row. So let's say in this case d was 3. So in the recursive calls we will keep on tracking the depth with every subsequent call. So whenever the depth is equal to d minus 1, let's say here the depth is 1, here the depth is 2, and we have to introduce level at 3. So at 2 we are going to introduce new row. So what I'm going to do is take a store it in a temporary variable, store the left subtree in a temporary variable, introduce a new row, and then introduce that row in between. Okay, the same thing. 2, the left subtree is there, attaching left row, and the left of this 1 will be the left subtree. Something like this. Okay, so let's try to make a pseudo code for the DFS. Firstly, what are all the functions we require? Let's say we are writing an insert function and we are having a root, we are having a value, we are having d, we are having current depth. We are having current depth, and we are going to call this function whenever the d is greater than equal to 2. If d is equal to 1, that is we have to introduce the level on introduce the node on the first level. What we are going to do is we are going to do new node with the current value, and the left of this node, or just read the problem statement. If the depth is 1, that means there is no depth equal to 1 at all, then create a tree node with the value well as the new root of the whole original tree, and the original tree is the new root slab subtree. So the whole tree will become the left subtree of this new node, and this new node will become the root. So this is already mentioned in the problem statement. So this case we can handle in our main function or our calling function. This can be our DFS function or helper function. So what will our helper function look like? First of all, we have to see. So whenever if current depth equal to d minus 1, if current depth is equal to d minus 1, it means at this level we have to do something. If we are not at this level, what we are going to do is, or maybe you can say in the else part, just make the insert call on the left part, root dot left, and this is root dot right, value depth current depth plus 1, current depth plus 1, because the depth is getting increased. If we are at a specific depth, that is at this depth we have to do the processing, we'll do something. If we are not at this depth, what we are going to do is we'll just move to the next level by increasing the current depth. Let's say at 2, 4, 1, we were at this level now, and we have to introduce d at 3. So d is greater than the current depth, so we will move next. So we will be at this level with the depth value equal to 2. Here the depth value was equal to 1. It means the caller of this function will pass the current depth as 1 in the starting. And what is our terminating case? Whenever recursion will stop, that is going to be root equal to null. In this case we can directly return. We are not returning any value from this function. So at d current depth equal to d minus 1. So here what we have to do? We have a root, and we have a root left, and we have a root right. It can either be a subtree or a null value. So what we have to do is temporary left, temporary right. We are taking two variables and storing these subtrees in this variable. Right left, root ka left and root ka right. Okay. So we have these two temporary variables and we are just removing this connection and adding a new value 1 1, and after this value we can have this value, this value which is stored in the temporary left, temporary right. Let me write code for you. Let's say tree node t temporary is equal to you can say node dot left. Let's take a temporary variable for our node. Now root dot left is equal to new node with that value, and that root dot left is going to be temporary. In this way, this is going to make this connection. For let's say we have 8 here, it is going to introduce another node, this connection, and this the same thing we are going to do with the right subtree. Okay, let's write a exact code on the LeetCode to help you more understand this problem. Okay, I hope you understood this approach. And what is the time complexity here? Let's say we have to introduce on the last level, it's going to be order of n, and the recursion stack involved in the DFS, which is order of height. Let's start writing code for this problem. First of all, we have to handle the depth equal to 1 explicitly. Let's say depth equal to 1. In this case, what we have to do is, as given in the problem statement, that the whole tree will be the left tree of the current new node. So tree node n equal to new tree node, and here I can pass the value. Okay, new node is introduced, and the new node dot left is equal to our complete root, and we can directly return new node. Now the case where the depth is 1 is completely handled, and the other case, for the other case we can write our insert function where we are going to pass our root value depth current depth. It's going to be function call, and after this function what we can do is we can directly return our root, because the root will remain the same. Private void insert tree node root int value int d int current depth. Okay, so what is our terminating case? If root is equal to null, we don't have to do anything. If current depth is equal to depth minus 1, we have to do the processing on one level below. So, and in the else case, what we can do is we can call our recursive function root dot left with the same value, the same depth, current depth will be increased. What about the right subtree? For the right subtree, we'll go root dot left, right. Now what we have to do is tree node temporary variable is equal to root dot left. Now the root dot left will equal to new tree node with the new value, and root dot left is going to be the temporary left subtree which we have stored, and we are going to do the same thing with the right subtree. Root dot right, and the root dot right will be updated, and root dot right is equal to the temporary tree. I hope this is done. Yeah. Let's try to test over sample test cases. Let's update the input variable. Current depth is 1 initially because we are starting at a level 1 and the root is at level 1. Tree node tree. This is already defined and we don't have to define it again. Load of compilation errors. Okay, the sample test cases are passed. Let's try to submit the problem. It got submitted successfully. Hope you understood the problem. Thank you guys. You can try the level order traversal or the BFS by your own and let me know in the comment section. Bye bye.